Hello friends, this is tutorial program from EA Technologies. The topic that we have picked today, we have picked it as signal assembly, a normal topic. Today we are going to discuss how to think logic for programming, and this is with the help of Java. So we'll take an example in Java, then we'll think about that. So let's start going further. Thinking logic is not different than any other task that we think and used to do in our day-to-day activity. Take some example of our day-to-day activities tasks, that is planning to go to college or to work, traveling from source to destination, to reach up to the destination, attending a class or a meeting in college or workplace, and then finishing lunch, etc. So why not take a real-time scenario and then try to think what is a task and then how we use to act on a task, and how task or our day-to-day activity can help us to think logically or analyze a program and think logically and write a program. Okay, moving to the next slide, we have taken an example of task that is fill a bucket with 5 liters of water. It's a very simple task. Now, what is required to do this task? It's now the tools and logistics that is required to act on this task, and subtask of this task, the small activities that we use to take to finish the bigger requirement of bigger task. If you look at tools and logistics, the requirement is to fill a bucket with 5 liters of water. We need a bucket. It's very clear with the requirement. To count 5 liters of water, we need a liter or a mug, which can pour a liter of water at a time. And then third and very important logistic that we are looking for, source of water. Because without water, we cannot fill a bucket with 5 liters of water. Now look at the second scenario, where we are going to divide this bigger task into small subtasks or sub-actions. If you look at these actions, the first one is collect all requirement in logistics that is required to finish this task. Look for source of water nearby. Walk to the source of water. Pour a liter of water in bucket with help of mug. And repeat above action 5 times, because we need 5 liters of water, and at a time we are going to pour 1 liter of water in the bucket. So repeatedly we have to do this task 5 times to fill the bucket with 5 liters of water, and then inform you are done with your task. So this is the simple division of, or a simple, simply we can break down the task into the logistic part and a sub-task or sub-action part. Moving further, what is the requirement for a programming? So if you have a requirement to write a program to construct a table of 5, and that's the action that we have. So to finish this action, what is required here and how we should think? So it is good to write the output, what we are looking for out of this program, into a paper. If you look at this output, the size, the output should look like, or it will look like 5 into 1 equal to 5, 5 into 2 equal to 10, 5 into 3 equal to 15, nothing but the table of 5, so 5 to 15. But if you look at this output and try to observe it, you can see that we are doing some action repeatedly. So there is a calculation that is going on repeatedly. So whenever you can see that some task in your program is going repeatedly, it says that there is a requirement of loop. So that's a very quick way to identify that you need a loop to finish this programming task. Now, as we divided our action into logistic and sub-action, here also we can divide it into logistic, tools and sub-actions. Now, tools and logistics in case of programming will be the stubs available with programming. So you should have the knowledge of programming or the language that you have picked. You should know that how your language behaving with variables, what kind of loops you have, how you can make decision in your language that you pick to finish this program. Now look at the logistic part. You can identify that you need a variable to hold the input that is given you as a file. You need another integer variable to run with the index 1, 2, 3, 4, 5 in the loop. If you look at this, 5 into 1, 5 into 2, 5 into 3, 5 into 4 to run your loop. And then obviously you need a loop to take the repeated action. And then if it is Java, I can use system.out.println to print the result on the console. Now, if you look at the subtask and subaction part, the subaction could be or will be write the method name from where your program will start, assign value 5 to a variable. The variable will hold the input value that is given you as 5. Assign initial index value 1 to one variable from where the index will start, and then it will increase from 1 to 2, 2 to 3, 3 to 4. Then start a loop. Display the mathematical calculation on the console. The 5 into 1 equal to 5, 5 into 2 equal to 10, and end the loop. So like this you can finish this program. Now look at how this program will look like exactly if you write in Java. So obviously anything in Java you have to write with the class. So first you will define a class thing in Java, the very first line, and then your action will start from public static void main, that is the main method from where your program will start actually doing the action. Then obviously the logistic was to have a variable to hold the input value 5. So we have a variable called input for table, and it's a type of int. So we are defining or assigning the variable as a subaction in action using the logistic, that is nothing but the variable available in Java or the data type available in Java. And then obviously you can start your loop with index value. Index initially it will be initialized with 1 because you have to start from 1 and then 2, 3, 4, 5, 6. And then your index will go till 10 because the action that you have to do repeatedly, you have to do 10 times. So your loop will go till 10 and then you have to increase your index, which will help you in calculation and display as well. Now the next line inside the loop will be display the result. So you will write your system.out.println, which will write your result onto the console. And then obviously if you look at the structure, the first thing will be 5, that is nothing but your input for table. Second thing will be into to the index, because initially index will be 1, then 2, then 3. So 5 into 1 equal to 5, 5 into 2 equal to 10, 5 into 3 equal to 50. So to display it, you will write 5 into your index variable that will be increasing every time in a loop. So 10 times it will increase from 1 to 10, and then you will display equal to on the console, and then your mathematical calculation here within the bracket. If you look at this, you need your input variable, input, and then you are multiplying it with the index. And obviously you have to end the loop and your main method and the class and come out. It's a working example. Please write down this program, and then in Java you can see the same result that we were seeing in previous page. And thanks for watching the video. This is a YouTube tutorial program from VBI Technologies that is situated in Hyderabad. Please subscribe to our channel for more videos like this, and write your comment and feedback for Better Tomorrow. Thanks again.